is factoring trinomials. And trinomials just means tri is 3, so we have 3 pieces, okay? And that usually just means we're going to have quadratics, right? And so this is the quadratic section, so that's why we're doing this. So the first one, let's just look at it. Number 5, I have x squared plus 14x plus 45. So the first thing you want to look for always is there a greatest common factor? Is there something that I can take out of each of those that they have in common? So we first look at the numbers. We have a 1, a 14, and a 45. Can something go into all of those? No, just 1, but we're not going to pull out a 1, right? Yeah. Then we look at the variable. Do they all have at least one x? No. So we are actually going to move on to the next method because there are no greatest common factors in this. So the next part we do is, most people call it the AC method. Okay? So if you recall this, it's going to be called the AC method. Okay? And the reason for this is hopefully on Monday you guys talked about how to take these and get A, B, and C out of it. So when I'm looking for A is always in front of what? I heard X, but X squared. Okay, A is the one in front of X squared. So A is this one. So in this case, what is A? 1. It's the coefficient. It's just the number. B is always the one in front of the X. So in this case, B is what? What number is in front of the X? 14. Good. And then C is the constant. So in this case, it's 45. Okay. So it's very important to do this piece first to get your A, B, and C, because it'll just help you. Okay. It's a good habit to do that because as we get into other things, you're gonna want the A, B, and C. Okay. All right. So now the AC method, it's called this because you take A and you multiply it by C. That's the first step. So in this case, A times C is 1 times 45, right? Which is just 45. So in this case, A times C is 45. I would write the steps down somewhere, okay? All right, from there, you want to make a factor tree. So you want to make perfect factors of 45. So what times what gives me 45? Just give me one of them. 9 times 5, good. And then I don't want you to ever forget about the negative also. We can do a -9 times a -5. A negative times a negative is still a positive. So I want you to remember that too, because sometimes you need that. Any other factors that you can think of? Which one? I thought I heard 3 times. No, I need 45. So what times 3 gives me 45 though? 15, good. So I can have 15 times 3. Or don't forget the negative, I can have -15 times -3. And then we can also have 45 times 1, right? If we wanted to. And negative, I'm running out of room, but we could have 45 and 1, and then the same thing negative. Now, you'll learn that you don't necessarily have to keep going because the goal is you want the factors that when I multiply them, they equal the A times the C. But when I add them together, so let's do a different color. When I add them together, Okay, the sum is going to be B. So in this case, B is 14, right? And so I'm going to go and I'm going to take these factors. We know that 9 times 5 is the 45, but what is the 9 plus the 5? 14. And so that first one you gave me is actually the correct one because it matches B. Now you could keep going if you needed to. This one would be a negative 14. This one would be an 18, right? But you see, we happen to get it on the first try, okay? And as you do this more and more, like you'll get used to it. You'll start seeing like, okay, A times C gives me this. What plus what gives me the B? You'll start seeing it, okay? Yeah, so it's probably ringing a bell. So again, first step, A times C, make the factors, and then those factors, when you add them, you want the sum to give you B. Okay? All right, so from there, we're going to rewrite this middle piece with the factors. Okay? So make a little box. So I'm going to rewrite the original problem. I'm going to say, okay, we've got x squared, and then I'm going to put over here the plus 45. Oops, not over there. Put it over there. But instead of the 14, I'm going to use the new factors I just found, which were plus 9 and plus 5. So I'm going to say plus 9x plus 5x. Does everyone see where the 9x and the 5x came from? So it's very important. If you read the note, I don't know if you read the note from the sub, but if we don't understand this by second semester, Algebra 2 is going to feel like you're taking Russian 4. Does anyone know how to speak Russian? Russian 4. Okay. Basically, if we can't get factoring down, second semester is going to be rough. Okay, so that's why we take a lot of time here. All right. Now we're going to separate this into two pieces. Okay, so we're going to take the first part and the second part. We're going to make two little pieces. And we're going to take the greatest common factor out of each piece. Okay? So out of the purple square, what can be taken out of both of those? Just x, right? Good. So just x can be taken out. And so if I do x squared divided by x, what do I get? X. And if I do 9x divided by x, what do I get? 9. Good. Okay. Then I'm going to do the second part. So the second part is the green box. What can be taken out of 5x and 45? The 5, right? Okay, so 5x divided by 5, what's left? X. And then 45 divided by 5. What is it? 9. Okay, so what did, I don't know if you see this, but these are the same. Yes? So what's kind of cool is with this, I can rewrite it as if I were dividing the x plus the 9 out of everything. So it's almost like another greatest common factor. Let's see if I might need more room. I'm going to rewrite it on a separate one real quick. Just because I ran out of room. So I had x x plus 9 plus 5, x plus 9. Okay. Everyone's here, yes? Okay. Now, remember when we have terms, they're connected by multiplication. So this is one term, and this is one term, because in between, there's an addition, right? Is there anything in common on the two terms? Yeah. Yes, the thing we just did, right? The x plus 9. So my greatest common factor is x plus 9. It's kind of weird, but I can take x plus 9 out of each of these. And so if I say, okay, if I take this and I do x plus 9, what's left? X. And if I do the same thing over here, what's left? 5. This is your final factor. Because right here on this first part, when I did x plus 9 divided by x plus 9, this x was left. And so it went here. And then when I divided by x plus 9 over here, the plus 5 was left. So it went here. So these went here. Because remember, that was my greatest common factor for both the yellow term and this green term. Lots of greatest common factors, yep. Now, if you ever don't trust yourself, what's neat about these is I can FOIL this, right? And so FOIL, or some of you used to do the box method, is x times x. So x times x in this case is x squared. X times 5 is 5x. And then we go to the other one, 9 times x and 9 times 5. And then if you combine like terms, I end up with the original equation. So I know I did it right. Okay? So it's a nice check that if you distribute, you got to distribute 4 times, right? You got to give this x to both and this 9 to both. So it's 4 multiplications. All right, let's try another one. But this green box is your answer, just so you know. Okay, this green box, that would have been your answer for factoring. Okay.